All right, we're continuing our sequences, and today we're looking at arithmetic sequences. An arithmetic sequence is where a constant is added to each term to get to the next term. All right, so we got a simple one down here. What did I add to 3 to get to 6? 3. And so I'm just going to go through my sequence and make sure that that works for every given possibility that I see. And yes, I see that if I added 3 to each term, I would get the next term. Now, what you have there is your new vocabulary word for the day. It is called a common difference. And what's common when you subtract each term? And we use the letter D to represent the common difference. And that's going to be in any arithmetic sequence. Okay, next thing you want to stop and write these down because this is huge for the whole chapter. The difference between a recursive formula and an explicit formula. Remember we talked about these a little bit last week. Recursive means you have to look back. That's supposed to be a smiley face. You have to look back to find the next term. An explicit formula gets you right there. Now, notice we have our a sub n and a sub n minus 1. This means any term right now. And this means the term before it. Wow, the pen's not being good today. And that means the term before it. Now over here, notice what we got. We've got any term, the first term, and there's our D for common difference. In the next example, I'll show you how the explicit formula is much more powerful than the recursive formula. Okay, so here we are with our first example. Given the sequence 100, 97, 94, 91, find the common difference is the first thing. Well, you always have to do that. Okay, what did I do to 100 to get to 97? I minused 3. I minus 3. I minus 3. Okay, so my common difference is that I added on a negative 3. So that's my common difference. Find the 10th term of this sequence. Sorry. All right, well, most of you will go right for the recursive. You'll see that you have the first term is 100, the second term is 97, the third term is 94, 91, and you'll just keep going. Minus 3, minus 3, minus 3, minus 3, minus 3, minus 3. And that's okay because I only gave you 10 terms to work with, so not that hard. But if I asked you to find, say, the 1000th term of this sequence, that would take a little longer, and that's why we have the explicit formula. All right. This says to find any term, we take the first term and add on n minus 1 differences. Now, it's not as hard as it looks. Let's just walk it through. This wanted us to find the 10th term of sequence A. We take the first term and add on, well, if you saw over here, n is 10. So we add on 10 minus 1 differences. And we know our difference is negative 3, so I can actually erase that and put a negative 3 there. All right, going further, We don't know what the 10th term is right now. We know it's this because we did the recursive to find it. But we take the first term, which is 100, and add on 9 differences. And there we go. The 10th term is 73. Now this whole 9 differences things, look up here. Remember, this is a difference. That was a difference of -3. I had 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how many differences there were between the first term and the 10th term. Just like if you look at your fingers. You have 5 fingers, but in between your fingers there are 4 spaces. So the explicit is much more powerful. We want you to understand the explicit formula. All right, example 2, once again, these easy ones, you guys will probably do the recursive till we get you to the hard ones, and then you'll understand the explicit is easier. Scott is saving to buy a guitar. He puts $42 aside, and he adds $8 each week. Okay, so the first week he had $42, and then he adds 8 each week. He needs 400. In which week will he have enough money? Well, we could keep doing this and doing this and doing this. Add 8 onto that. We get, what, 66? Add 8 onto that. This is going to take us forever. I think we're going to use the explicit formula. So let's go back here and let's grab that explicit formula. And let's start filling in the blanks that we know. Well, we know the common, let's see, A sub n. We're trying to find the 400th, oops, sorry, no, we're not, sorry. We're trying to find out 400. We know A sub something is going to equal 400. We do know the first term. It's 42. We don't know what n is. We don't know which week he will have enough money. But we do know the common difference is 8. And look at that. We have a formula now with only one unknown. So we just have to solve. 400 equals 42 plus 8n minus 8. 400 equals, well, 42 minus 8. We can do that and get 34. Minus 34 brings us 8n over here. Let's see, 400 minus 30, 370. So that's 370, whoops, 366. And let's see how many times is 8 going to 366. I don't have a calculator in front of me, so I have to do this out the long way. In 48 weeks. So we figured out here that n is 48. Right? That's what we figured out, n. So the 40th term of sequence A is, the 48th term of sequence A is when he'll have $400. Oops. Oh, we kind of extended the page there. There we go. Okay, the 4th term of an arithmetic sequence is 80, and the 12th term is 32. Find the common difference. Once again, I'm going to give myself a little visual. I always give myself a visual, and then I decide whether I want to do the explicit or the recursive. So the 4th term, they tell me, is 80. Notice we didn't start with the first term. And the 12th term is 32. Find the common difference. Well, as soon as they say common difference, we know this is an arithmetic sequence. And it makes sense because we're in the arithmetic sequence section, so yeah, there's going to be another type of sequence coming. That'll be in 2 days. So what did I add on to get to here? Well, once again, I'm going to use my explicit formula. All right. All right, sorry, I had a little interruption there. All right, so here's my explicit formula. Now, you look at it and you say, this doesn't help me because I don't know what my first term is. So, here comes a little upper level thinking, and this is why it's Algebra 2 and not Algebra 1. We've got to manipulate this formula a little bit. We do know what the 12th term is. We know the 12th term is 32. And we do know the 4th term is 80, but we don't know what our common difference is, and that's what they're asking me to find. But we do know this. If we make a sub 1 80, because in our mind, that's the first term we know. And we do know how many differences were added on to 80 to get me to 32. 1, 2, 3, 4, 5, 6, 7, 8. We know 8 differences were added on to 80, and that got me 32. All right, so I'm just going to do the math here. Minus 80, minus 80. So let's see, that gets me 8, that gets me 48 negative. So my common difference was negative 6. So let's see what that works. Let's see, negative 6, that would have been 74. That would have been 68. That would have been 62. That would have been 56. That would have been 50. That would have been 44. That would have been 38, and voila, it does work. So all I did was manipulate this. Now, if you're somebody who wanted to do this outright, you could have just said, okay, I'm going to make this my first term, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. And you could have just done it perfect substitution. The 9th term is found by taking the first term and adding on n minus 1 differences. Okay, a sub 9 is 32. My first term is 80 plus 8c. We get the same one. So even though they told you it is the 4th term, you can make it as the first term and just find your common difference because it's just a sequence. It just goes on and on and on and on. Okay, find the 5 arithmetic means between 2 and 23. Big words, but they are really simple to do. It's just like we've been doing. I'm going to give myself a visual. Whoops. I'm going to give myself a visual. Ah, there's the bell. And 5 arithmetic means simply mean the numbers in between 2 and 32, and I want to find 5 of them. All right, so I just plop down my explicit formula once again. And let's see. A sub n, a sub 1 I know, that's 2. And I've got, let's see, 1, 2, 3, 4, 5, 6, 7th. So this is my a sub 7. So n would be 7. Do I know my 7th term of this sequence? Yes, I do. It's 32. Awesome. Now I have a problem here with only one variable, so I can solve it. I find my common difference is 5. So now I just have to find my 5 arithmetic means, those are the numbers in between. So 2 plus 5 is 7, 12, 17, 22, and 27. And we're done. Bye.